Hello, everybody. This is Vinay Jusri. I'm the CEO of Severalnines. So it's now 10 o'clock. We shall be starting very shortly. Well, first of all, thank you for signing up for the webinar. So we are pretty excited to start doing webinars again, and this time we are doing it with our colleagues from Nextcloud. So today's topic, the top 5 tips to drive MariaDB Galera performance for Nextcloud, and a couple of housekeeping items. Ashraf, if you go to the next slide, please. So as mentioned, I am Vinay, and I'm the CEO of Severalnines. So I'll be the host today. You can ask any questions you might have through this Q&A chat. So just feel free. We will be answering the questions at the end of the webinar. You can also chat directly. So please do interact. We do like that. And maybe we can also answer any other sort of questions you might have. So our 2 speakers today, Björn is from the Nextcloud team, co-founder and the pre-sales lead. And then we have Ashraf, who is a senior support engineer at Severalnines. We are looking forward to this session. So next slide, Ashraf. So this is the agenda. We'll talk about the Nextcloud architecture. That's something which Björn will cover, and then we'll talk about the database architecture, sort of design. Then we'll look into the proxy. So this is what Ashraf will go deep into. MariaDB performance, InnoDB performance tuning. Even the Nextcloud application performance tuning, and then at the end we will have collected your questions, and hopefully we'll be able to answer that. So we expect to finish just a few minutes before 11 a.m. in Central European time. Okay, next slide. So we have a poll. We have 2 polls during this webinar. So it would be great if you could answer it. So if we can just launch the first poll. Shamim? So how many users do you have on your Nextcloud platform? Under 100 users, 101 to 1,000 users, 1,001 to 5,000 users, 5,001 to 100,000 users, or more than 100,000 users? Or maybe you haven't deployed Nextcloud yet, or maybe it's just a test environment and you don't have any live users yet on it. It would be great if you could vote. And I don't know how to do that, but I hope we can also share the results of the poll right after you have voted. So we'll give it a minute or so for people to vote. Thank you for your participation. Okay, I think we can just close the poll now, and maybe we can present the results. Shamim?
Okay.
Okay, good, great. So here are the the results of the poll. So we have a pretty good mix here. We have 23% under 100, about 26% between 100 and 1,000, and then it's spread between 1,000 to up to 5,000, 5,000 to 100,000, and we also have we also have a user who has more than 100,000 users. That's great to see. And then we do also have folks who have not got any production users yet on. Okay, good. And if you didn't manage to to vote in the poll, please you can always just write it in the chat, right? I think it is good information for us. But I think it's good to see that that there is a there is a good mix out there. Okay, we're going to close that, and so on to you, Björn, for the Nextcloud architecture.
Thanks, Vinay, for the introduction, and welcome everybody. I'm Björn Schießle, co-founder from Nextcloud and the team lead of the PreSales team. I will give you a quick introduction about the Nextcloud architecture before we move on to the database details. So Nextcloud is a content collaboration platform which consists of 4 components. It's Nextcloud Files, Talk, Groupware, and Office. It's completely modular, so you can set up the system the way you want it with exactly the functionality you want to have. Today, we want to focus on Nextcloud Files because it's the most interesting part when it comes to database performance. On the next slide, we see just a high-level architecture. Nextcloud runs on the typical LAMP stack. So you typically have a Linux server with a web server, Apache or Nginx, and database cluster, MariaDB with Galera and PHP and at the backend. This shows you a high-level diagram about the architecture of a complete Nextcloud hub system. So you have typically multiple web servers where the Nextcloud application runs on. The load balancer distributes the load through the web servers. You have a storage backend or cluster. You have Redis for caching. Of course, you have your identity management system, and you have your database cluster, which will be most important in today's webinar. And then if you also use the other components, you might have an Office server for the online Office integration, and for Nextcloud Talk, of course, you need a bunch of additional components, but we will keep this aside. That's just for an overview that you see how a complete Nextcloud hub architecture looks like. On the next slide, you see then the architecture, how it looks for the setup we are talking today. So for typical Nextcloud Files system, you see here we remove the whole Office components and Talk components. So you stick at the end to the web servers, the database cluster, storage, your identity and access management, and your Redis server. On the next slide, just to give you an idea how Nextcloud scales, and that's something which is quite unique to Nextcloud because the same code base, the same software runs on really small systems for 150 users or even less, to huge clusters for up to 100,000 users and more. And if you reach this limit, if you even want to scale to millions of users, and actually we have users who have multiple millions of users on a Nextcloud system, we have even a global scale architecture, which you can think about as a cluster of clusters. So you can have many different independent clusters, which you can maintain separately. But from an end user perspective, it will look like and feel like one single Nextcloud instance. Here you see the architecture of a typical large Nextcloud setup now in a bit more details. You see you have multiple web servers, your database cluster, which has in front of it a load balancer, and then you have a master and multiple slaves. You have again the identity access management system. For large systems, you won't have a single Redis server, but you want to have a cluster of Redis servers, and you have your storage. And the nice thing is that this can be scaled quite well, also linearly. So you can add multiple web servers, and if you run out of power on the web server side, you can add additional web servers. But what typically happens is that the database will become some kind of bottleneck at some point in time. We will learn about this later in the webinar, but at some point it doesn't help a lot to add additional database nodes. So this will become the bottleneck, especially as that the database is a quite central component of Nextcloud. For every request you send to Nextcloud, probably basically the database is involved. It can be just to set up the file system. It can be to load configuration of certain Nextcloud apps and so on. So basically all requests needs to interact in some way with the database. So you can imagine that for really, really large systems, it makes a lot of sense to focus on the database and to scale this further. So that's why we are here today, actually. At this point, I want to hand over to Ashraf to dive deep into the database cluster. But before we do this, we have another poll for you.
Yeah, so thank you, Björn. This was a very quick introduction to the architecture. And folks, again, there is the ability to ask questions. So, please use the questions and answers box. So, and this is, it says poll 1, but actually it's the second poll, the second and the last poll. So I promise no more polls for today, if you don't like polls. Before we get into the database, performance and the database architecture, can you tell us what database setup are you using today? Are you using a single instance MySQL MariaDB? Are you using an active standby MariaDB instance with replication, or even active standby MySQL with replication? Are you using a Galera cluster? Are you using Postgres, or are you using some other database? So it would be great if you could let us know. It also help us, let's say, maybe tune a little bit our own material based on what you folks are answering. So we'll give it a minute or so for you all to vote. Thank you for your participation. Let's see. Okay. All right. So we're going to be closing the poll shortly. Last chance to vote. Okay, let's close the poll then, Shamim, and show the results. All right, so we have a quorum here. There's a lot of people running single instance MySQL MariaDB, and this is this is interesting. I'm going to ask both Björn and Ashraf about their comments shortly, but then let's continue. Actually, there's about 18% who is, oh, actually, sorry, 36%, just over a third who are running Galera Cluster. And then we have a little bit of active standby, sort of MariaDB, as well as Postgres. But we can see that very few are running others, right? So the majority seems to be running MySQL or MariaDB, and half of the audience approximately is running on a single instance, right? Björn, let me ask you this. I mean, what are your thoughts about this, Björn?
Yeah, I think this matches quite well the first poll, because if I have the user numbers you have in mind, it's makes sense that a lot of you are still using a single instance of MariaDB, but some of you already had to scale out to a cluster. And I'm sure once your Nextcloud instance will grow further, some of you who are running a single instance at the moment will come to the point where you will need a cluster as well. So I think the webinar is perfect fit for the attendees here.
Excellent, excellent. And Ashraf, this is really for you. I mean, now that you're going to talk about the database part, what are your thoughts around this? Single instance, you see it quite often?
Yeah, it's interesting, and I think this webinar just suits all of this, the majority of the attendees here. So, yeah.
Okay, great, thank you. So now we're going to leave this to you, Ashraf, to take us through the database part of things. And folks, just another reminder, remember there is the question and answers box down at the bottom, so please feel free to ask any questions. Thank you. And back to you, Ashraf.
Thank you, Vinay and Björn. Hello, everyone. My name is Ashraf Sharif, and I'm a support engineer from Severalnines. For my part of this presentation, I'm going to share with you some tips on how to drive MariaDB cluster performance for Nextcloud. So on this part of my presentation, I'm going to cover the Nextcloud database characteristics, their architecture design, and also some performance tuning and best practices. Let's get started with an overview of Nextcloud database characteristic. So Nextcloud is built on top of PHP and make use of PDO modules as a way to communicate with the database layer. PDO is basically an abstraction layer. So for database, and it offers a unified interface to access many different databases. There are a number of benefits with PDO. Like for example, you can use prepared statement, which is much more secure. And you can, in terms of usability, there are a number of components built into the framework, and it is reusable to a number of database management system, from as lightweight as SQLite up to fully featured database systems like MySQL, MariaDB, PostgreSQL, or Oracle. And Nextcloud supports a number of database backend, like SQLite, which is usually only good for testing and proof of concept only. If you want to run on production, you have to pick either MySQL, MariaDB, PostgreSQL, or Oracle. This is all possible thanks to the PDO abstraction that Nextcloud is using. So the database mostly stores the file metadata and also the administration data, while the actual file are physically stored under the Nextcloud /data on the web server. So it's also important to understand the database workload, whether it is read or write intensive. This will give us a better view of which database operation needs to focus on for us to tune and to scale. So to calculate the read-write ratio, you have to divide the corresponding operation with the total operations and then multiply it by 100. So on the right side, there you can see an example, SQL example that we can use to measure the read-write ratio. But this one is only accurate since the last MariaDB restart. So the result here is relative to the uptime. So if you have higher MariaDB uptime, so the result will be much more accurate. And we can tell from the output here that our database workload is read intensive, with 91% read operations and 8% of write operations. Therefore, we should focus more on scaling out replicas and cache some expensive queries. So this is not a production workload here, but however, we should get a similar result pattern for most of the workloads. And also, if your application is very write intensive, one way to scale out the performance is to have more nodes that can accept writes. So a common method in MariaDB is to partition a huge table into multiple shards, so you can allow more writes happening to that particular table. And generally, sharding increases the complexity of data storage, and very often it requires modification to your application. But this is not the case with Nextcloud. I have performed some database query aggregations for common tasks that usually will be performed by one active Nextcloud user. Like this information was collected by basically just turning on the MariaDB general log and then let the user access the Nextcloud application through a web browser and then perform some common tasks. This is very simple, straightforward measurement on a plain standalone MariaDB server without any caching layer or database load balancer. I would then categorize the query and calculate the database connections and count the number of queries that were processed by the MariaDB server. This does not present a production workload again, but this will give us a good ground understanding that and what we can expect if multiple users are simultaneously connected at the same time. As you can see, each task produces its own sets of SQL queries, and some of them even require many database connections to complete a specific task. For a simple, like for example, for a simple one file upload, okay? So Nextcloud will generate 5 database connections and around 35 writes operations to the database server. And if you upload 5 files in one shot, it can also be considered a heavy operation, as you can compare with other similar tasks like moving or copying multiple files at one time. So as a conclusion here, there are a lot of database operations being performed by the database server, and the database server must be tuned and configured properly so you get the optimal performance. Now we look into the architecture design. The architecture design can hugely influence the MariaDB cluster service availability and performance. Before we move further, with the architecture design, let me make a quick introduction to MariaDB Cluster. So it's basically a MariaDB server, and then you patch it with a RightSet Replication API, also known as WS, right? So this API requires a provider. So basically to provide the ability for group communication and for replication, and we call this Galera. It only supports transactional database storage engine like InnoDB or ExtraDB. And for MariaDB, this means InnoDB storage engine. WSREP API is a part of MariaDB since MariaDB 10.1, which makes it simpler to deploy. You just need to enable some configuration options without any additional package or load library. Ideally, a Galera cluster should consist of odd number of nodes to prevent split brain, starting with 1, 3, 5, and so on. 1 is basically not a cluster, but it is possible to run as one node cluster. So we should start at 3 as minimum. Galera Cluster has a number of cool features like multi-master replication with automatic membership control and joining. So a joiner node will be automatically synchronized with the correct state before it is allowed to be part of the cluster. Galera handles this process automatically with the help of some backup tools like MariaBackup, MySQL Dump, or rsync. It can be configured to use many slash threads, so you can improve the replication parallelism. Another feature is it keeps the same look and feel like MySQL and MariaDB, so which will be very handy for application developer. So and reduce the learning curve tremendously. Some of the benefits include that all transactions are guaranteed, almost no slave lag, and we can easily achieve read scalability for our Nextcloud read intensive application. At the time of this presentation, the latest MariaDB version is MariaDB 10.5 with Galera version 4. So Galera version 4 was first introduced in MariaDB 10.4.6, which is way ahead of Percona encodership. It has some significant improvements like streaming replication, new Galera system table, and synchronization functions. Well, if you would like to use the older version, I would recommend to use any database version with Galera version 4. Okay, so the Galera replication works by replicating the write sets from the originator node to the receiver node. So in this example here, imagine a write impression hits the originator node, which is in the blue icon there. And the write operation will first be committed as a transaction on the originator node, and then it will produce a set of binary events. However, before returning OK to the client, the commit process takes a bit longer because Galera will then encapsulate the transaction into a write set with all the necessary details like the primary key, like Galera sequence number, and also the binary raw events itself that have been generated by the commit event previously. Then the write set is broadcasted to all the receiver nodes. And right after that, all write sets will be certified by the Galera Application plugin on every database node. So to confirm whether the write set can be applied or not. In case of conflicts on one of the receiver nodes, the write set then will be just discarded, and the original transaction on the originator node will be rolled back. So this is why Galera only support transactional storage engines like InnoDB. So if the write set passes the certification process, it will be queued on the slave queue before being applied by the Galera slave applier thread on the receiver nodes asynchronously. Finally, back on the originator node, it will return OK to the client. So basically, the commit happens asynchronously at real time, at the same time, but the applying happens asynchronously. So this is known as a virtually synchronous replication. Okay, so Galera treats every query as a transaction. So it can be rolled back if needed, right? In one transaction, you can have multiple queries. It could be select, insert, update, or delete. Started with begin, and then you close it with commit or rollback. So RightSet is basically a transaction that only contains write operations. So in this table here, I've added the number of RightSets highlighted in green, generated by Galera for read operations. So if for read operations, there is no RightSet, if you can see. And the Nextcloud generates around, if you look at uploading one file, it will generate around 20 inserts and 15 updates, which means a total of 35 write operations. However, only 33 write sets are generated by Galera because there are 2 write operations happening in a single transaction. So all of these write sets here are transported from the originator node and then are certified by Galera before being applied on the receiver nodes using the Galera slave thread. So the bigger the write sets, the more certification tests have to be performed by Galera synchronously at the same time. So the RightSet applying process usually happens a bit later, but most of the time it happens almost instantaneously with the help of the multi-threaded slave. So up until this point, you should understand how Galera application works. There can be many factors that can influence the writes, the reads, and the replication performance, from the server resources, MariaDB, InnoDB configuration, network latency, because of the RightSet broadcasting and certification process, and then the Galera flow control, which basically throttles the Galera application if necessary, and parallel slave threads, which is the number of threads that Galera will use to apply the certified RightSet. As shown in the previous diagram, Galera cluster writes and replication performance are highly dependent on network latency and flow control. So for network latency, one important thing is to measure the round trip using the networking tools like ping or traceroute. So the lower the round trip time, the RTT, to the farthest node in the cluster, the better. So think twice if you want to separate nodes in a Galera cluster through different network or different switch or even different geographical location. It is better to have them in the same network segment for the lowest latency. Galera use a flow control mechanism to throttle the replication flow if necessary. So basically, Galera can throttle down the replication stream to give a chance for the slower nodes to keep up with the replication stream. So this is why there is no replication lag in Galera. And this is also why all the database nodes in a Galera cluster are tightly coupled. So unlike MariaDB replication or MySQL replication. Therefore, you should have uniform hardware specs for all nodes to not let the other nodes slow down the replication performance. And then slave threads, if you have more slave threads, more parallelism can happen when applying the certified RightSet. And the standard MariaDB and InnoDB configuration and tuning also apply for this one, and for buffer, caches, thread queries, and indexing. Okay, so since MariaDB Galera nodes are all equal, which means all nodes can process reads and writes, we can make use of a load balancer on top of the cluster to improve the throughput and also performance. So load balancer can increase the queries throughput by distributing the load to more than one nodes, then performing query routing for efficient database processing. And then you can also maximize the resource utilization. You can also improve the service availability, the connection queuing, connection throttling, and also it provides transparency to the clients because with load balancer, you can have a single endpoint access for the database service. There are many load balancer options for the MariaDB Galera cluster available in the market. The most popular ones are Proxy Scale, MariaDB Max Scale, and Azure Proxy. Therefore, when designing the MariaDB database cluster architecture, we have to count the network latency between all nodes, a uniform server specs for all nodes. We have to also tune MariaDB, Galera, and InnoDB. And we also have to add a load balancer on top of the database cluster. In a centralized topology, load balancer, or we can also call it reverse proxy, is located between the data and presentation layer. So to eliminate a single point of failure, 2 or more reverse proxy are necessary, and they should be tied together with an active passive virtual IP address. So it can provide better transparency, because clients just need to use one single endpoint to access the data tier. Despite requiring additional nodes and another different tier, it is far simpler to manage the centralized topology if compared to the distributed topology. In my humble opinion, this is the best approach that we can recommend for Nextcloud database usage. In a distributed topology, people tend to use IT infrastructure automation tools like Chef, Puppet, Ansible to streamline and automate the deployment and management of multiple load balancer instances. When co-locating with the application server, you bring the reverse proxy layer closer to the application and eliminate the single point of failure. However, the number of reverse proxies is equal to the number of application nodes, which means if you scale the application up, the number of proxies will be increasing as well, which would make the management more complex, and probably it could degrade the performance of the database health check service. So Nextcloud database workload requires a single writer setup because of the PDO module that it uses. So PDO does not support multiple database hosts per PDO instance. And another important factor is some of the Nextcloud tables do not have an explicitly primary key defined, especially on the older Nextcloud version. I believe in the latest version 21, only one table got no primary key, but the rest they'll come with primary key. Primary key is very important. It's very, very critical basically in Galera, because Galera use primary key as a identifier to certify write sets and make sure the rows it modifies are not conflicting with other write sets. So to eliminate the risk of multi-writer conflicts, we have to redirect all writes to one node at a time, as highlighted by the blue icons. Some load balancers have built-in capability to perform read-write splitting, like PreSales and MaxScale. These two load balancers understand until layer 7 of OSI model to inspect the queries and route them accordingly. For PreSales, you have to set the query rules where all queries that are not started with select, something like that, should be forwarded to a destination host group with single backend server. Like for MariaDB MaxScale, you can create a service with a read-write split router option, and you should be good. For other TCP-based forwarders, which is only listed up to layer 3 of the OSI models, like Azure Proxy, Nginx, or F5, you can customize them to handle the incoming connections with session stickiness algorithm, like IP hash. So it will always hit the same backend MariaDB server. However, this is not the best way, because all connections will end up hitting to this very same database server, which defeats the purpose of load balancing. There are two types of I/O operations on MySQL. We have sequential I/O-oriented files and also random I/O-oriented files. Storage layer is critical in InnoDB, mostly for write operations. So use at least SSD, enterprise-grade SSD for MySQL data directory, or at least the random I/O-oriented files. You can also offload all the sequential files to a slower disk, like a spindle disk. Most of the time, Red 10 is generally good for MariaDB workloads with ext4 or XFS file system on Linux. You can also mount your file system with the -no time option, so to skip update to the last access time in inodes on the file system, which can avoid some disk 6. So this architecture diagram illustrates the recommended architecture for our database and load balancer tiers for 1,000 to 10,000 Nextcloud users. We have a 3-node active MariaDB cluster in one network segment, with active passive proxy SQL nodes in front of the database cluster for query routing and and load balancing. The PreSales should be configured with read-write splitting by sending all writes to a single Galera node, and the reads can be distributed to the remaining nodes. The active PreSales node is basically the node that holds the virtual IP address. So a virtual IP address is a floating IP that exists only on one of the participating nodes. So if the active PreSales server goes down, the virtual IP address will be taken over by the secondary PreSales server without any changes required on the application side. For a much bigger scale, the architecture should be expanded with at least one asynchronous slave through the standard MariaDB replication, replicating from one of the MariaDB cluster nodes. So this slave node can be used for analytics and backup purposes. Remember, in Galera, the replication performance is as fast as the slowest node. So we don't want to run the heavy read-only jobs like batch jobs, analytics, backups on one of the Galera nodes because it will affect the overall performance. We should forward these jobs to a loosely coupled node like the slave node instead. Also, we can add an additional caching layer with Redis. This can be a Redis cluster or Redis master slave or a standalone Redis server. This caching layer can be put together within the application tier if you want. This architecture should be able to handle 10,000 to 100,000 users provided with very good hardware specs. So if you want to go beyond this, I believe you have to use a Nextcloud Federation feature instead. Okay, next is the last topic, which is the performance tuning for MariaDB Cluster. Okay, first the tuning motivation here. So our motivation behind the performance tuning is to try to improve the database reads and writes with minimal trade-off as much as possible. So I'll try to be more specific here by using a specific database vendor and version with specific Nextcloud version 19.0.1 on the stable repository for 10,000 Nextcloud users. So basically the Nextcloud usage might vary, but for this performance tuning, I have put an estimation for the total Nextcloud database size to be around 10 GB. The total database size is one of the most important key components that we have to look at when you start to tune the database server, because it can influence the disk-related and buffer-related parameters. Most of the suggested MariaDB configuration options in this slide are also applicable to MySQL-based database servers. This is just a repeated slide, a refresh to just to refresh our mind about the key performance factor for MariaDB server and also the Galera application. The performance tuning will be based on the highlighted components like the MariaDB buffer, the threads, as well as Galera-related configuration. Okay, so general MariaDB tuning. If the total database nodes is 3 and all of them are behind the load balancer like PreSales, 500 maximum connection is a good starting point, since you have PreSales on top of it, which is smart enough to handle thousands of client connections with connection pooling and multiplexing. So this value can be set dynamically. So if you need to increase it, you can just dynamically increase it on the MariaDB server without a restart. If we are really after the performance, we can turn off performance schema to get a 3 to 5% performance boost with a trade-off, no in-depth monitoring and instrumentation. So the binary log can also have a bit of performance overhead, especially if we turn on the sync Bing log parameter. By disabling this, we could have around 10% performance improvement. It's recommended to use skip name resolve. So MariaDB will need to rely on a DNS resolver to resolve the client's IP address. So we have seen cases where an overloaded or unstable DNS resolver had caused slowness to PreSales and MariaDB server. So if it is necessary to use hostname or FQDN in your environment, use the /etc/host mapping, which will guarantee the resolving time and make it more efficient. Another thing is max allowed packet, which can be set to 32 meg or higher. You can go up to 1 gig if you heavily rely on MySQL DOM for backup. You can also turn off syn bin lock to improve performance, especially when you enable binary lock for the asynchronous replication slave. So set this value to 1 for full durability with a 20 to 30% performance overhead. Okay, so for the InnoDB tuning, the most important variable in InnoDB is the buffer pool size. Commonly, we are going to try to fit the total database data and index size into the buffer pool. As in this example, our plan was trying to fit the 10 gigabyte of database size into the buffer pool. So for instance, a MariaDB user with a 32 gigabyte of RAM should be set at least 20 gigabyte of buffer pool. And then should be able to fit in our targeted 10 gigabyte database size for Nextcloud. So the next one is the InnoDB buffer pool instances, which highly depends on the InnoDB buffer pool size. So commonly, if the buffer pool size is 8 gigabyte or bigger, we should set it to 8 instances. So the buffer pool is divided into 8 different instances with 1 gigabyte in each size. So having multiple instances can reduce the contention happening in the buffer pool. But this option is deprecated in MariaDB 10.5, since there are a number of improvements in this aspect that having more than one buffer pool is no longer necessary. If set, it will be ignored by MariaDB. TX isolation, this is transaction isolation, should be set to read committed as recommended by Nextcloud. So the default value in Galera is called repeatable read, which is a higher isolation level. For InnoDB IO capacity, this totally depends on the disk subsystem where the MySQL data directory resides. So the default value might be good for a low-end disk. For enterprise SATA SSD, it should have more IO capacity, like for example, 1000. So do not blindly believe what the vendor tells you on the IOPS the disk can perform. So to get the best value for this is to perform some benchmarks and measure the disk IOPS by yourself using IOStat or any other disk monitoring system tools. Let's say, for example, after performing the disk benchmark, we get a value around 5,000 to 8,000 IOPS, right? So we can then specify the lower number, 5,000, for this variable. Similar things apply to the InnoDB IO capacity max, which is the IOPS hard limit for the MariaDB to use. So don't set these two values too high, like 10,000 or 15,000, because it may cause the data to be removed from the buffers too quickly, which will reduce the effectiveness of caching in the buffer pool. For the flush method, if you have a direct attached local disk, or direct is usually the best option. Some more tuning for InnoDB. The InnoDB read-write IO threads should be set higher, but not over the total number of CPU cores available. So for InnoDB log file size, this value can be increased higher to save this IO with a trade-off of slower crash recovery during startup. However, in Galera, it doesn't really matter, because as long as we have other operational nodes to cover the service, while the node is starting up and recovering, right? The last one is InnoDB flush log TRX commit. So the default value is 1, which is full durability with a bit of performance impact. Similarly, we can set this variable to 0 or 2 to relax the log flushing, since we have other Galera nodes to cover for write durability. So I would recommend setting this to 0, which we should be able to see up to 1x or even 2x write performance improvement. InnoDB buffer pool best practice. Okay, InnoDB is utilizing this buffer pool as like the working area, and this one of the most important tunings that needs to be done correctly to get most of the InnoDB. So if the total database data and index can fit into the buffer pool, MariaDB will be very likely not going to hit the disk to read the data. So reading a row from this is it's way slower than reading the same row directly from RAM, even if you're running on a very good disk subsystem like Flash and NVMe. It's still slower and more expensive if compared to RAM. When starting up a MariaDB, the first read of rows will copy the pages into RAM, and then the subsequent reads will take advantage of the faster performance of RAM. A warm-up buffer pool consists of all the hot data already in the buffer pool for maximum performance. It is very common for MariaDB to be a bit slower after startup without a warm-up buffer pool. In MariaDB 10.5, there are two options that are already enabled by default to automate the buffer pool warm-up. We call it InnoDB buffer pool dump at shutdown and InnoDB buffer pool load at startup. And then check the buffer pool hit rate every now and then, and make sure you get the maximum ratio. For example, 999 to over 1000 or 1000 over 1000. Otherwise, the remaining missed hits basically means MariaDB had hit the disk to fetch the rows from the disk. If your data can fit into the buffer pool, you would usually get this value 1000 over 1000. If the database size is larger than the buffer pool, the 1000 over 1000 simply indicates that the frequently accessed rows or the hot data can fit into the buffer pool. But please be reminded that most of the points mentioned here are true only for read operations. For write operations, MariaDB still requires hitting the disk to flush the data and make the data persistent. Okay, for Galera, the default WSF slave thread for MariaDB Galera is 1, which means no parallelism. So set this value to the number of CPU cores the server has, or you can set it to ×2 if you have hyperthreading enabled. But this value should not exceed the WSF cert depth distance value. It is the value of average distance between the highest and the lowest Galera sequence number that can be applied in parallel. So to get the best value of WSREP cert depth distance, let the cluster run for a couple of days and then find a stable point of value. For example, let's say you get 48 as the WSREP cert depth distance value, and you should have 4 cores with hyperthreading enabled. You should start with 8 WSREP slave threads, and the maximum value is 48. The next thing is to increase the Gcache size under the WSREP provide options. So the default value is pretty low, which is 128 megabyte. So if you have more disk space allocated to the MariaDB data directory, you can increase this value up to half the size of your projected database size, right? So the bigger the value, the higher the chance of a Galera nodes can join without the need of to have full synchronization. Okay, some Galera best practices. If you opt for multi-writer Galera setup, make sure every table has an explicit primary key defined. Some tables in Nextcloud do not have a primary key, but you can just simply add a primary key with an auto-increment column. So more writers in Galera will increase the chance of RightSet conflicts and might cause the transaction to be rolled back. And always remember that in MariaDB, a rollback transaction is always slower than the committed transaction. You can use the example query here to get all the tables that are not suitable to run in Galera, probably because of the lack of primary key or special indexing. To add a primary key, just use the auto table add column command. DDL operations like alter, create, truncate, drop might cause the cluster to stall until the operation completes. So I recommend running the DDL operations during a maintenance window or during the low peak hours, or even use online schema change tools like PT online schema change or Ghost. For Nextcloud, upgrading to the next version might trigger DDL operations, so it is better to perform the Nextcloud upgrade during the maintenance window. Since Galera applies replication flow control, if one of the node gets slow, it is very likely the replication performance for the whole cluster will get slow as well. So I would recommend running heavy operations like backup, reporting, or analytics during low peak hours, or schedule it to run on a synchronized replication slave, which basically has no impact on the Galera cluster. Okay, so the last slide here about caching. So we can improve overall Nextcloud server performance with caching, where frequently requested objects are stored in memory for faster retrieval. We can use Redis to offload the MariaDB cluster from handling the transactional file locking job. Redis is a very fast key value store and can handle this type of job very, very well. In our test, we have seen up to 40 to 50% reduction on the database hits with a specific task, like editing a single text file. And no write contention to one of the busiest Nextcloud tables called OC file logs. So if Redis is running on the same server as Nextcloud, configure it to listen on the Unix socket for security and performance. Using the Unix socket will reduce the TCP network overhead. Redis cluster is also supported with PHP Redis 3 and later. Authentication is also supported since PHP Redis 4.2.1. So you just need to define all Redis nodes in the cluster config.php file. So you won't need any load balancer for Redis at all. You can also use Redis to handle session management for PHP. And if you have a Redis cluster, you can specify all the Redis nodes there. So it becomes like a centralized caching cluster for Nextcloud and PHP. Okay, that's it, I guess. That basically concludes my presentation for the day. We can move, I think we can move to the Q&A session. Over to you, Vinay.
Yeah, thank you, Ashraf. That's a lot of information, folks. So there's been questions around whether the replay will be available. It will be available. We'll upload it before the end of the week. So that was quite a lot of information, and let me jump into some questions. So there is a Q&A box at the bottom, so please use that if you have any questions. Let me go through them. So Ashraf, one question for you. Do you have counters when using group folders with many affected users? I guess I don't know if you have measured this counter, or maybe Björn, I don't know if you would know that, if we have any counters when using group folders.
No, unfortunately, I don't have any numbers for group folders. So if you didn't have done some tests, I think we don't have any numbers right now.
Yeah. Okay. Okay. Let me continue here. So something for you, Ashraf, about virtually no slag lave. We have some, and this is from Sasha. We have some problems about running read-write split on max scale for certain tasks, which do not seem to be in a single transaction. Is there a way to mitigate such problems, like create guest on the master, read guest user on the slave fails, as it is not yet synchronized?
Yeah, in Galera, there is a variable that we can choose to encounter this, to mitigate this kind of issue. We call it WSRAP sync wait. So by setting this to 1, Galera cluster will always wait for the operation to complete before replying. Like instead of so for that kind of for particular transaction, so it will be when it executes the transaction, and once it applies to the other nodes, then when you request it, So it will wait for all other transactions before it to be applied first. Then you will get the most updated data. But this going to reduce the parallelism, because virtually you have to wait for the transaction to be applied to all nodes first before you get the most updated data. In this case, you can choose what kind of query that you want to have this option to be enabled. So because it's a session variable, you can set it per session. Before you start doing this kind of select, set the variable to WSREP sync weight to 1, then you will be good. You will get the most updated data. But you cannot apply this to globally, because it's going to reduce the parallelism of WSREP left thread.
Okay, thank you. So let's get the next question from Torsten. Is read-write split possible when using F5 big IP as proxy load balancer?
Unfortunately, I have a very limited experience with F5, but I believe not so, because but you can extend it, right? You can extend the F5 with more scripting and stuff to figure out which one is the active the active node that should receive writes only. But it's not like natively supported. You have to extend it using F5. But like PreSales and MaxScale, it comes out of the box. Just set it there, then it knows where to route the query already.
Okay. One more question here from Harald. Is PT online schema change supported for MariaDB Galera? I thought it is only supported for Percona cluster, Percona XpressDB cluster.
Yes, it is supported. I've used it in even in production. So it's basically it just add a trigger to the table that you want to alter. So like that trigger then will redirect the incoming rows, entries, pages, whatever, to the new table, something like that. So it's kind of like for general MySQL-based database system.
Right. Thank you, Ashraf. So Björn, a question for you. You presented the MariaDB MariaDB Galera Cluster's role in Nextcloud files. Does it also play a role in talk, groupware, and Office integration?
It's most important for Nextcloud files because there we store the most information. Of course, it also plays some role in the other components. For example, Cooper, we store the calendars and the address books in the database. For talk, the chat history. So it also plays some role there, but the most important role it plays in Nextcloud files. Okay,
excellent. Thank you. We have one more question from Matthias here. Do you have experience with Nextcloud's server-side encryption enabled in terms of performance?
I think from a database perspective, there shouldn't be a big difference. Of course, we will write some additional information to the database and read it there, but the main performance difference you will observe is because the encryption, decryption of the files by writing and reading them. So I think the database can be ignored here in the sense of performance drops.
Right, it's more a CPU operation in the application than to encrypt and decrypt. Yeah. Okay, we have a question from Johan. Which is the best and why? Proxy SQL, MaxScale, or HAProxy? Currently using MaxScale.
Well, MaxScale is built by MariaDB for MariaDB. So MaxScale is very good. The read-write splitting is really good enough. It's very doing its job fantastically. And also, I would if you already have MaxScale and MariaDB, I would recommend you to just stick with it because it also, like the MaxScale is also very modular. You can use it as a bin log server as well, and you can also use it for like other purposes. So in terms of performance, I don't really see much different. It's just usability and the ecosystem of the product itself. So if you are not familiar with MariaDB MaxScale, because it is pretty modular, it's not like a, so you have to enable this module, and then service, and then listeners, and a lot of stuff you have to know first. Like for PreSales, it's pretty straightforward. You have query rules. It's like a firewall rules. Like you define the rules, then this rule should go, this query should go there. This kind of query should go there. So PreSales is good if you don't choose MaxScale. But if you already have MaxScale, just keep on doing it. If you are new to database routing, proxy, like database proxying, and load balancer, I recommend to use PreSales to start. And PreSales supports all, supports Percona, the Codership one, and also the MariaDB.
Yeah. Okay. I don't see any more questions. So Björn and Ashraf, thank you very much for your participation. Thank you everybody for joining us for this webinar. You know, it was a good session. And again, the replay will be available. You know, hopefully by before the end of the week. So thanks all. Have a good rest of the day, and you know, hopefully we'll do more of these events, you know, together with the Nextcloud team later. And if you have any other questions that you know, that you come up with, or any other topics you'd like us to address, just please you know, please just contact us, you know, and we'll be happy to do that. Okay, thank you all. Goodbye.